picking up in 12.6, as we just discussed, I'm going to hit and skip and try and make sure we get through a variety of things and not totally miss the end of the lesson. So, with that in mind, for right now, I'm going to skip Justice and Tamika, and we're going to talk about Rashawn. If we have time, we will come back to Justice and Tamika. Okay? Now, if you recall yesterday where we left off, we had just talked about the idea that if something is fair, the expected value is 0. Okay? There's equal chances of winning and equal chances of losing, so to speak. Okay? Or whatever the case is. So, let's talk about Rashawn. Rashawn offers you a game where you roll a number cube, aka you roll a die. If the roll is less than 5, you get the number of points rolled. If not, Rashawn gets the points rolled. Is the game fair or unfair? If it is unfair, which player has the advantage?
So there's 6 sides.
It is a regular number cube, so 6 sides, regular die, yes.
If you roll less than a 5, so that includes 5, like 5 and less, or just less than 5?
Less than 5.
Less than 5 would not include 5.
Okay, but that's still what the unfair.
Okay.
That's a problem.
And here's the deal. So let's talk about one thing first of all. We've got to talk about the probability of each possible outcome, right? So what are the different outcomes? You could roll a
5.
A 5.
Or not a 5. Oh,
Well,
no.
There's more options than that. When you're rolling a die, what could you roll?
1, 2, 6.
1, 2, 3, 4, 5, or 6. Yes? Those are your different possibilities you can roll. So let's talk probability real quick. The probability of rolling a 1 is what? 1 out of 6. This is going to be pretty basic right here. Just got to get our brains on the right track. The probability of rolling a 2. 1 out of 6. The probability of rolling a 3. 1 out of 6. Probability of rolling a 4. 1 out of 6. Probability of rolling a 5. 1 out of 6. And the probability of rolling a 6. 1 out of 6. Okay, so that's just kind of, we've got our probabilities in our mind, right? They're all 1/6, but I just wanted to get that stated. Now, when we talk about expected value, okay, Rashawn offers you a game. So it looks like on my notes, I did this from my point of view. Okay, so how do I get points? I get points by rolling less than 5. And what do I get in the way of points? You get the number of points rolled, yes? So we need to talk about the possible outcome and the probability of getting that outcome. So I could roll a 1, yes? If I roll a 1, how many points do I get?
1.
1. And what's the probability I roll a 1? 1 out of 6. I could roll a 2. How many points do I get if I roll a 2?
2.
2. And what's the probability I roll a 2? 1 out of 6. Plus, I could roll a 3. How many points do I get if I roll a 3? 3. And what's the probability I roll a 3? 1 out of 6. Plus, I could roll a 4. How many points do I get if I roll a 4? 4. And what's the possibility of rolling a 4? 1 out of 6. Now, are you still with me? I could roll a 5. How many points do I get if I roll a 5?
0.
I don't get any points, but what happens?
He
gets 5 points. What's that count for me?
negative 5.
Minus 5. That's 5 that I don't get. And what's the chance of those 5 points being taken away from me?
1 out of 6.
1 out of 6. So you've got to have a negative there. Plus,
Negative 6.
I could roll a 6, but I don't get those 6 points. Rashawn gets those. So that's a negative 6, and the chance of rolling a 6 is 1 out of 6.
It's like some tedious work.
Okay, it is. It is. Now, We can make this a little bit easier so you don't have to rely on the calculator.
I'll put them over 1.
What is 1 times 1/6?
1/6.
Fair enough. You multiply by 1, you get 1/6. These others are easy too if you give me a chance. What is 2 times 1/6?
1/3.
2/6 reduces to 1/3. I'm actually going to leave it as 2/6 because I have to add these later and I want a common denominator.
Good thinking.
Okay? So 2 over 1 times 1 over 6 is 2/6. Plus, what's 3 times 1/6?
3/6.
Right? 4 times a sixth?
4/6.
4/6. Negative 5 times a sixth?
Negative 5/6.
Negative 5/6. And negative 6 times a sixth?
Negative
Negative
6.
6/6.
Negative 6/6. Now, yes, like about half of those will reduce, but I didn't reduce them because now my next step is to add them. As long as you have a common denominator, you just keep the denominator and
At the top.
add the top, right? So, 1 plus 2 plus 3 plus 4.
That's 10.
That's 10.
Subtract.
Negative 5 and negative 6 is
Negative
negative 11. 10 plus negative 11
Negative.
minus 1/6. Okay. There is my expected value.
That's unfair.
That's unfair, isn't it? Okay. If I got a 0, it'd be fair. Rashawn and I would have equal opportunity of winning this game. This is unfair because my expected value is not 0. Who's more likely to win?
Roshan.
Because my expected value came up negative, and I did this from my viewpoint. We could have just as easily have switched it, right? Done it from Rashawn's viewpoint, given him the positive, me the negative. But okay, so game is unfair, and I wrote skewed to Rashawn's advantage, but advantage to Rashawn.
Why is everybody using math up here?
Yep, not probably.
What?
Everybody is cheating.
They're all hacking the system. Like,
Unfair. Advantage to Rashawn. Are you talking about how everyone creates a game that is in their advantage? Well,
Hey, I would too if I
Speak-
was them.
are you going to create a game that's in the other person's advantage?
no, I think we should have
No.
a fair chance.
Especially if I'm
Now,
putting money on it.
It would be good if we could just create a fair game, but. Okay. Does that give you a little bit more insight as to what we're talking about here, right? Okay. Let's flip to the next page then. We've got a Silicon Valley problem to talk about.
Is that a real thing?
Silicon Valley?
I feel like
Yes.
Well, this says Silicon Valley Company, but
No.
so I don't know about that. But the Silicon Valley is a real place. I mean,
That's where like
California.
Think
It's
of
and I don't know if it's truly an actual name or just a name they use to reference.
I think it's just like a reference because I'm
Yeah.
pretty sure like Apple is part of Silicon Valley, but it's really Cupertino, California.
But
Okay. Geographic.
let's go.
Geography.
The Silicon Valley Company. Let's focus. Manufactures tables and computers. I think that's supposed to be tablets. Oh my goodness.
Tables. Makes sense.
Yeah.
That's supposed to be tablets and computers. Their tablets, there we go, are covered by a warranty for 1 year. So if the tablet fails, the company replaces it. Since the failure rate of their model Tab 5000 tablet is high, the head production has a plan for replacing certain components inside the Tab 5000 and calling the new model the Tab 5001.
Oh, that's
If you were the head of production, would you recommend switching to selling the Tab 5001? Now, obviously, we can look at these charts and we can kind of guess. but we're going to do the actual math behind it. I want the data to support our answer. Okay, so we've got the Tab 5000. It costs $100 for them to produce it. They sell it for $150. So are you seeing a profit here?
No.
But we have to take into account there are 5% that fail within the first year. And when it fails, it costs the company $130 to replace it. Okay?
It costs them more to replace it than to take it.
I got nothing there. Now, the Tab 5001. The cost to produce it is $105. The price, they're going to sell it for $150. It only has a 1% fail chance, but it costs the company $135 to replace it. And I don't know if that has to do with shipping and other, type fees, but. Okay, so let's start. By looking at the Tab 5000.
500.
Yeah.
So nitpicky here. Gotta keep me on my toes, huh? Okay, thank you. Tab 5000. If we're trying to figure out, if you're the head of production, would you recommend switching to selling the Tab 5001? What do we need to figure out? We need to basically look at how much they're going to make, right? So let's figure out profit. Okay, so what do we know? They're going to sell it for
150.
$150. Now, do they get all of that $150?
No.
No. What do we have to take away from that $150?
Production cost.
Production cost of
100.
$100. So now we're down to a $50 profit. But what else do we have to take into account?
5%.
So percent rate, yeah.
There's a 5% failure rate, and those 5% that fail, what's that going to cost the company?
130.
$130. So do you see where I'm going to go with this? I'm going to go minus 5% times 130. Does that make sense there? Okay. So you've got to do the 150 minus 100, which I know that's 50. You've got to figure out 5% of 130 and then subtract it. That's going to give me my expected profit. So do some math, please. And what would 43.5 be in terms of dollars and cents?
$43.50.
There you go. Okay,
I was getting there.
so the Tab 5000 is going to earn the company a profit of $43.50 on average, based on the expected failures rate. Okay, let's do the same for the Tab 5001. What do we know about the Tab 5001?
It's cheap. Well, not cheaper.
Technically, it's not cheaper. It's the same price, which is kind of unusual for the newer model, right? So it's 150. What do we know about that 150?
It costs 105 to make.
Cost 105 to make. So you have to subtract off the 105, which means we're already down to $45. And
Minus 0.01 times 135.
minus 1% of 135, because there's a 1% chance they're going to have to pay 135. So the expected profit when you do all the button pushing is, I heard 40 something. $43.65. That's for the Tab 5001. Okay. The question was, if you were the head of production, would you recommend switching to selling the Tab 5001?
No.
Yeah, you're making 15 cents more. Down 15 cents will add up new cylinder.
Okay.
I would say
Well, and
buy a
ones
reliable
that
tablet
only
instead of one that can fail.
1% fail.
Well, and here's the deal though. So, the Tab 5001, it makes only 15 cents more, but it does make a smidge more. But on top of it, doesn't it also have a lower failure rate? Okay, which is not technically what I'm supposed to be looking at if I'm just looking at the numbers, but that's a number. Okay, so it does have a lower failure rate, which is something to take into consideration. Who wants to mess with having to get something replaced, even if it is free to you? You guys are still young and not adults, but it's a pain if you have to get something replaced. Even if it is under warranty and free, you know? So, I would say switch to the Tab 5001 since expected profit is higher and less likely to fail. Switch to Tab 5001. Profit is higher. Fail rate is lower. Okay? Okay. Now, we're not done talking about the Tab 5000, 5001. Jocelyn doesn't like my writing.
F. Whatever that, I don't know what that says.
Fail.
Oh.
I don't know if it helps if I dot my I or not, but it does look sloppy.
It feels like it said foul. Like F-O-U-L.
The foul rate is lower. Fail rate is lower. Okay. Additional data is collected for the Tab 5000, 5001. The production and replacement costs for the Tab 5001 remain unchanged. Okay, so Tab 5001 stays as is. Tab 5000, they're going to change some stuff in each part here. So, the production replacement cost for the Tab 5001 increased by $10. What would the expected profit be for the Tab 5000 now? What'd you say? They need to get rid of it? Is that what you're saying?
Yeah.
Okay, well, we'll get there. Okay, so the production and replacement cost. So what's that mean if they increased by $10? They're going to become what now?
160. Oh wait, which part? Oh, 140.
The production cost. Wait, okay. So replacement cost goes from 130 to
140.
140. The production cost goes from 100 to 110. Are you there? I just felt like I needed to write those numbers where I'd know them. What would be the expected profit for the Tab 5001 now?
So we just did what we just did.
Pretty much. We're just changing numbers. So Tab 5000,
150 minus 110 minus.
expected profit. So the one thing that didn't change is it still is selling for 150. Now instead of subtracting 100, it cost 110 to produce it. And still has a fail rate of 5%, but it cost 140 to replace it. So 5% of 140. Yeesh. That was a big hit, wasn't it?
You wrote 500 again.
Oh my gosh.
Okay.
Goodness. Thank you. I don't know what I'm doing here. I guess that extra zero just doesn't seem necessary in my brain. Okay. Now, the fail rate for the Tab 5001 increased by 1%. Dang it, that was one of the good selling points. What would the expected profit be for the Tab 5001? So now we've got to recalculate here for the 5,001 expected profit. So if it increased by 1%, what's that mean?
6. Nope. 2%.
Okay, it goes to 2%, right? Okay, so did anything else change? Nope. So it's still going to be the selling price of 150 minus the production cost of 105. Instead of 1% of 135, it's 2% of 135. What'd you say? Okay, so $42.30. Okay. As a consultant for the company, what would you recommend they do to maximize their profits?
Increase it by a percentage.
Okay, what are you saying, Jocelyn?
And like tying them all together.
Well, yeah, kind of. Like as we've proceeded here, like they want to maximize profit in general. I mean, my profit for the 5,000 just went down to $33. Profit for the tab 5,001 went down a little bit, $42.30. There's two suggestions I could go with. Does Olivia have a point? Olivia, what was your suggestion?
Getting rid of it.
Getting rid of
5,000.
the 5,000. Do we still have to have the old model?
No.
No. And especially now that the 5,000 has only a profit of $33. If you get rid of the 5,000, what has to happen? Everyone has to buy the 5,001, which has a better profit, right? Okay. The other thing that I would maybe consider, the 5,001's selling for the same price the 5,000 sold for. What could you maybe do there?
Up the price.
Could you up the price a little bit? I mean, up the price by $10 and it's going to make a little bit of a difference. So those are the two options that you could suggest. Discontinue the tab 5,000. Consider increasing the selling price of the 5,001. Okay? Discontinue the tab 5,000. Consider increasing selling price of tab 5,001. Okay? Okay. Questions about the tab 5,000, 5,001? Or the tab 500 as I like to keep writing. Okay. Time-wise, I might be okay, but I'm going to skip Gabriella just to be safe. And we're going to go back and talk about some binomial distributions again. Okay? Okay. This is using binomial distributions to make decisions. So again, using the probability to make decisions. An airport shuttle has a capacity of 6 passengers. The company takes 8 reservations for each trip because 25% of their reservations do not show up. Is this a reasonable policy? They can carry 6, but they're going to book 8 every time. Just because they have a quarter of their people not show up.
No, because one of these times everyone's going to show up and you're going to be screwed.
Well, so here's what it comes down to. Is I want to look at the numbers, and I agree. One of these times it's going to happen. Now, what the company is going to argue is if it happens a very small percent of the time, then they're going to say, this is reasonable.
I'm confused what this is even asking about.
Is it reasonable that even though their shuttle bus only holds 6, that they will schedule 8 people to ride at a time? Like, you call in advance and set this up. You don't just show up. You call in advance and you just hope that when you show up, you can get on at this point. Whereas usually you just assume you schedule something, it's going to work. Okay, so we're going to look at the number here. Now, with this in mind, let's look at what we have here. We know what?
25%.
25% what?
Don't. Yeah.
Do not show up. How many do show up then?
75.
75% chance of showing up, yes? So I'm going to say 75% do show up. Okay? Just trying to gather data here. Now, what we've got to look at is the probability that 7 show up and the probability that 8 show up. Folks, there's a hint in the middle of your paper. You get another little friendly reminder. Guess what's back? It never left. Last 3 lessons. Binomial probability formula. Okay. In order to figure out the probability that 7 show up and the probability that 8 show up, we need to do the binomial probability. Okay, this falls into that binomial experiment category. So we're going to look at probability of 7 and 8 showing up. Okay, so let's work to set this up. So I'm going to start with probability of 7 showing up. Okay, which means I'm finding, to begin with, P of 7. Probability of 7 showing up. Now, with that in mind, go back to our formula. NCR. But we're trying to find 7, so that's my R value. What's N? How many are we going out of?
6.
Not 6, 8. Because they regularly take 8 reservations. So we're going to do 8C7 times P. What's the probability of showing up?
0.25. Oh, no, 0.75.
Okay, 0.75 raised to the R value, which is 7. Times, officially it's 1 minus P. So that officially be 1 minus 0.75. So I'm going to write 1 minus 0.75, but what could you also write there? I'm going to go with 0.25. Okay. That's 0.25 raised to the what?
8 minus 7.
8 minus 7. And 8 minus 7 is a 1. So it ends up being 0.25 to the first. Okay. Grab your calculator. And do the button pushing. So basically we need 8C7 times 0.75 to the 7. times 0.25 to the first.
I got negative 6.9 repeating.
You hit the wrong button.
I got 0.26667.
Okay. I have it written on my notes as 0.267. I wrote it with 3 decimal places. Yeah, as soon as you said negative, I knew something. You hit a wrong button there. Okay. So right there, the probability of 7 showing up is 26.7%. Okay. Now, what else do we need to look at?
Oh, probability 8.
We need to look at the probability of 8 showing up.
8.
So probability of 8 showing up, 8C 8. So basically the all 8 show up times P to the R, so 0.75 to the 8 times,
1 minus 1, 0.75.
officially it's 1 minus 0.75, which is just going to be 0.25 raised to the 8 minus 8, which is 0. No negatives again.
Yeah, I got negative again.
Okay, yeah, you're hitting something wrong.
And what is it doing?
0 point what?
Are you putting in parentheses?
Oh, I just deleted it. I got 0.02 or something. I don't know.
I don't think I like that either.
I don't.
Not what I've written down, at least.
Let me try. My calculator is going to
Well, you should just be able to do 8C8 times 0.75 to the 8 times, well, what is 0.25 to the 0? Anything raised to 0 is
0. Oh, 1.
1. Officially, I know 8C8 is also
1.
1. The only thing I really need to do is 0.75 to the 8 here. I should see everyone with calculators working.
It just says math.
0.100.
Point 1001, she said, I think. So I have mine rounded to 0.100. Okay. So what's the probability together that 7 and 8 show up? If we put the probability of 7 and 8 together, that's putting what? 0.267 together and 0.100 together? What's that add up to be? 0.367.
3.
268.
The 0.1 lines up with the 2.
Oh.
Okay. Now, okay. The probability that 7 or 8 people show up, so basically that more than 6 show up, is 0.367, or in other words, 36.7%.
We should write 37 now? Or no?
Either way. Okay. With that in mind, is it a reasonable policy to go ahead and make 8 reservations even though they can only transport 6? Over a third of the time, they're going to have extra people standing around that they don't have a ride for. Is that a reasonable policy if you're running a good business? Not in my mind. Now, again, if it was a really small percent, maybe. Okay, so I have that the probability that more reservations show up than the van can carry is 36.7%. A third of the trips are over full, so this is not a reasonable policy. Okay, so however much of that you would like to write is up to you. Probability that more reservations show up than the van can carry is 36.7%. A third of the trips are over full, so not a reasonable policy. One third of trips are over full or over capacity, so not a reasonable policy. Okay.
Especially now my mom's on there, she brings like 8 bags.
Okay, guys. We got one more. And we're not going to necessarily get all the way through it, but we're going to talk about what you would have to do. Fair enough? Okay. A play calls for a crowd of 12 extras with non-speaking parts. Because 10% of the extras have not shown up in the past, the director selects 15 students as extras. Find the probability that 12 extras show up to the performance. Probability that 15 extras show up to the performance, and probability that more than 12 extras show up to the performance. Okay? So, let's get some information. 10% of the extras have what?
Not sure.
Not shown up. What does that mean? But if 10% don't,
90% do.
90% do. Are we okay with that?
Yes.
Okay, so 90% do show up. Now, they're asking us to start with the probability that 12 show up. So in order to do the probability that 12 show up, how can we set up our formula?
And
Going back to our formula here, right? NCR. 12 out of how many?
Oh, wait. Well,
12 out of 15. So your N value is
15.
15. So 15 C12 times P. What's P?
90.
The 90%, because we're trying to find the probability that 12 do show up, so it's a probability that they show up, so 0.90, or in other words, 0.9, raised to the R, which is 12, times,
1 minus 0.9.
officially it's 1 minus 0.9. I'm going to write that up above here. But what do we know about 1 minus 0.9? It's 0.1, it's 0.10. Raised to the 15 minus 12, or in other words, 3. Okay? See if do we have time to get an answer? We have time to get an answer real quick and then. Okay, here's your problem. Don't do 15 minus 12 here. Just put 3 there. Or if you want to put 15 minus 12 there, you're going to have to put in parentheses. So if we go back or at least the starting point, go back. Or I'm guessing that's an answer. It makes sense to, Yeah, as a decimal, 0.1285. Or in other words, it's about 13%. That's not a very good number, is it? That was the probability that 12 show up. Now, we're not going to get to do the math on all these, but let's talk about setup real quick. The second question was probability that what?
15.
15 show up. Okay, stay with me. We've still got a couple minutes. Yes? No? Okay, not as much as I thought. What would we set up here? This would be 15C
15.
15. So on and so forth, right?
Yeah.
Now, last question. What about more than 12? What would you have to do? More than 12 are what numbers?
13, 14, 15.
13, 14, 15. So in order to do that, you'd have to do the probability of 15, which you already have. You'd have to do the probability of 13, and you'd have to do the probability of 14, and then you would have to
Add them.
add them. Does that make sense? That would be for the probability of more than 12. Okay, you would do the probability of 15 plus 14 plus 13. Do your homework. Test next week.